first calculation is it asks us to find the area, which is what we're looking for. And what we have are the dimensions in inches. And it wants us to find the area in centimeters squared. So what we have is the dimensions. We know what unit we need, and we know we need to find the area. So what we don't have is a conversion factor to go from inches to centimeters squared. So let's do this. Let's take 8.5 inches, and then we got 11 inches. And then does anybody know the conversion for centimeters to inches? You may remember that from high school, or you may remember it from a summer program you did, or you may have already seen it in the chapter.
Isn't it 2.54 centimeters is 1 inch?
Yes, sir. Yes, sir. Excellent. So the conversion factor now we have, right? We're going to put this right here. 2.54 centimeters per 1 inch. All right, so now we just need to do the same calculation down here. Again, desired unit in the top, discarded unit on the bottom. And what do we have here? And then after we convert inches into centimeters, then we can do the area. What do we have here? 8.5. Go ahead.
I got 21.25 centimeters.
25 centimeters, good. And what about for the 11 times 2.54?
27.94 centimeters.
All right. Again, inches are going to cancel. You're left with centimeters. And then from here, we can calculate the area in centimeters squared. So 21.25 centimeters times 27.94 centimeters is going to give me the area of that sheet of paper in centimeters squared. Can somebody calculate that?
$593.725.
Okay, you said, say that again. You said
593.725.
all right, 593.725. And then if I ask you to report this in 3 sig figs, what would you do? Round it up or down?
Up, because the 7 will make it.
Yes.
The 7 will make the 3/4.
So that's gonna round. That's gonna cause that to round up. So we'll say 594 square centimeters. Got a different answer this morning, but I think somebody may have put in a wrong number or something during the multiplication. But it's fine. It's not a problem. But it's the process that matters. And not saying the number doesn't matter, but right now we are working through the conversion process. So, all right, let's do another one. Let's take D. We actually skipped D this morning, but I actually want to work D because D gives us a chance to think about. It gives us a chance to think about these multi-dimensional calculations. So we have a volume in inches cubed. All right, and it says the volume of an engine is 161 cubic inches. All right. And so when we think about that calculation and we want to go to liters. So we know if we get to centimeters cubed, we can also get to milliliters, and then from milliliters to liters, right? Because 1 centimeter cube, we talked about this the other day, 1 centimeter cube is the same as 1 milliliter, all right? So what's the conversion factor for inches to centimeters? We just did it. One inch is 2.54 centimeters. Is that right?
Yes, sir.
All right. So then if we say 1 inch and we cube that, we're going to do the same thing to the other side, 2.54 centimeters. And we're going to cube that. What do you get if you take 2.54 and cube it? 16 point something.
$16.387.
Okay. So 1 cubic inch, you said 16.4.
Yeah.
All right. So 16.4 cubic centimeters. All right. So that means that for every 16.4 cubic centimeters, that's the same as 16.4 milliliters. Following? Anybody not following? Because a cubic centimeter and a milliliter are the same. They're both units of volume. Are we good with that?
Yes, sir.
All right. So what conversion factor can I now set up to convert cubic inches into cubic centimeters? I can take that 161. Is that right? 161 cubic inches times what? What do I want in the top?
16.4 centimeters cubed over 1 inch cubed.
Good. Excellent. Right. And then the inches cubed that's gonna cancel. So what do I have in cubic centimeters? It'll be 161 times 16.4. Is that right? Can somebody run that calculation real quick? Let me get my calculator out too, so we can all be working
I
together.
got 2,640.4.
All right, let's say, and this is in cubic centimeters, yes?
Yes, sir.
All right, now we can interconvert cubic centimeters and milliliters because we know that 1 cubic centimeter is the same as 1 milliliter. So let's say that this is 0.4 milliliters. How do we convert that into liters? Because these two are equivalent. What's my conversion from milliliters to liters? What's the milli stand for again?
1,000.
1,000th with a TH on the end. So that means that there are 1,000 milliliters in every liter. And again, we're going from milliliters to liters. So a smaller unit to a larger unit. So that's times 1 liter over 1,000 milliliters. And we're going to cancel those out. And it's going to end up being 2.6404 liters, right? And we can take that and also take that down. Let's say I ask you to report that in 3 significant figures. What would your answer be?
2.64 times 10 squared.
Yeah, we don't need it in scientific notation because it's already to the tens, so we're good. So 2.64 liters. And you've seen this before, right? How many of you have ever paid attention to that with a car? It'll say it's a 3.6 liter engine or a 4 liter engine or 4.6 liter engine. Anybody, have y'all ever paid attention to that? Anybody? Any car people?
Yes, sir.
Yeah. my daughter is a car person. She loves cars, engines, and horsepower, and all types of stuff. But this is an example, of how you can determine the volume of an engine in both cubic inches or liters, right? And um, there's a more direct conversion, but I like this way better because it makes us go through understanding the units, and it also causes us to understand the equivalence between cubic centimeters and milliliters. All right. All right, let's do the next one, which is this one. We're gonna skip the F and G. We're gonna skip those. So when you turn this in, you won't have to turn those in. But let's do E. Put a page in here. So it says the estimated mass of the atmosphere, 5.6 times 10 to the 15th tons. That's what we have. All right. And it says we're trying to convert that into kilograms. That's what we're looking for. What we know is that we can go from pounds to kilograms and tons to pounds, but we need a conversion to go from both, from and to both. So let's go from, let's take tons. We're going to convert that into pounds. What's the conversion? Anybody know? It's a very simple conversion. How many pounds are in a ton? There are 2,000 pounds in a ton. All right. So can somebody convert that or go ahead and calculate that? Anybody got it yet? Anybody?
Is it 10 to the 15th or 10 to the 5th?
Oh, I'm sorry. 10 to the 15th. My bad.
I got 1.12 times 10 to the 19.
Okay, great. I'll take that. Same thing I got. 1.12 times 10 to the 19th.
Yes.
All right. And then we're going to take that number, and this is in pounds now. And then we're going to take that number in pounds and now convert it into kilograms. What's my conversion? From pounds to kilos, or from, pounds to kilos. We did this the other day. More kilograms in the top. Over what?
2.2
1,000
pounds.
grams. 1,000.
Well, no, we're not going from kilograms to grams now. We're going from kilograms to pounds. So there are 2.2 pounds in every kilo. All right. So now we're just gonna take this number and divide it by 2.2. Somebody tell me what you get there. Don't know. I'll speak out at once now. I don't want the internet to crash. So is that number divided by 2.2? I'm getting 5.01 times 10 to the 18. Anybody got that? I'm sorry, 5.1, not 01.
Yes, sir, I got that as well.
All right, 5.1 times 10 to the 18. All right, so that's our calculation. We had to go do two conversions. We had to convert tons to pounds and then pounds to kilos. And we had, you cannot do and this is the reason why this is important is because there's a topic that's coming up. We're going to be talking about the law of conservation of law of constant proportions. And every one of those problems is a conversion. And in order to do a conversion, you need a conversion factor. If you don't have a conversion factor, you can't convert. And so I know these seem like rudimentary conversions, pounds to kilograms, or, centimeters to inches, and so on and so forth. But it's the skill that you're developing. So when you see this in some other area, you're able to apply the same skill. So it's all conversions. It doesn't matter what you're converting. It's all conversions. All right, let's go to the next page and let's work these two problems right here. Let me crop this right quick. All right, we're gonna work let's work 15. This is an interesting problem. We're actually just gonna go from angstroms to meters and angstroms to feet. So let's do that. Put it right here. All right, it says hold up, I gotta move it over. A chemist 50 trillion angstrom run will be an archaeologist 10,900 cubit run. How long is 1 cubit in meters and feet? So let's just convert from angstroms to meters and angstroms to feet, and then we can go back and figure out the cubits. We can go back and figure that out. All right, so it's giving us the information. It's giving us 50 trillion angstroms. It's telling us the conversion between angstrom and centimeters, and it's asking us this information right here. How long is 1 cubit in meters and in feet? So we can, once we figure out the number of meters in 50 trillion angstroms and the number of feet in 50 trillion angstroms, we can convert that into cubits, because based on the information we have, 50 trillion angstroms is the same as 10,900 cubits, right? So these two are equivalent. All right, so let's do that. Let's do the angstroms to meters first. And this is 5.0 times 10 to the 13th angstroms. Because remember, it can't be 50 times 10 to the 12th because the number here needs to be greater than 1 but less than 10. So it's 5 times 10 to the 13th angstroms. And that's a little circle over the A. That's the symbol for angstroms. Right? And we're going to convert that into centimeters. So times 1 times 10 to the minus 8. Come on, Russell, tighten up. Did not try to do that. So 1 times 10 to the minus 8 centimeters per 1 angstrom. All right, questions about that? All right, that's our conversion. 1 angstrom is 1 times 10 to the minus 8 centimeters. So we're going to convert angstroms into centimeters. So let's convert that. All right, what do we get?
Wouldn't it be 5.0 times 10 to the 5th?
Excellent. That's exactly right. And that's in centimeters. All right. Now we can take that and convert centimeters into meters because we know the conversion there. That's a base unit. Meters is a base unit. So we're going to convert. Get this so I can get this shrink down a little bit. Centimeters to meters, which is we're going to take 1 meter over 1,000. I'm sorry, not 1,000. My bad. 100 centimeters. All right, 1 meter over 100 centimeters. Right now, keep in mind 100 is 10 to the second. But since it's in the denominator, when I do this calculation, that number is actually going to flip to the top, right? And so it's going to be basically multiplying 5 times 10 to the 5th times 10 to the minus 2, right? So when we do that, we're going to end up with 5.0 times 10 to the 3rd meters. Following? Anybody not following that? I mean, you don't have to think about that when you're doing it in a calculator. But when you have something like this, where it's 1 over 100 or 1 over 1 times 10 to the second, then that's going to actually flip up when you do that multiplication. All right. Questions? Any questions? All right. And then centimeters is going to cancel, of course. So we'll be left with meters. All right. Now we look at that. How long is this race? Anybody? How many kilometers is that? 5 times 10 to the 3rd meters is how many kilometers?
5.
5 kilometers. Excellent. Who was that?
Nazir, sir.
Yeah, nice work. It's a 5K race, right? Because 5 times 10 to the 3rd is the same as 5,000. And we know that there are 1,000 meters for every kilometer. So it's a 5K race. Let's go ahead and do that in feet. We can do a direct conversion from meters to feet if we so choose, or we could do yards, meters to yards, and then yards to feet. Which one do you want to do?
We can do feet to yards.
All right, long way. Good. I like that. Take the challenge. So we're going to say that 5 times 10 to the third meters times 1.09 yards over 1 meter. That's our conversion. We learned that the other day. What do we get from that?
$5,440 or 5.4 times 10 to the third.
Yards?
No, yeah, yards.
Mhm. All right, and then we're going to convert that into feet by taking this times 3 feet per yard. All right, what do we get from that? What do we want, like close to 16,000, somewhere up in there?
16,350 feet.
Right, so 16,350.
Yes, sir.
And then if I wanted to report this in the correct number of sig figs, let's say 3 sig figs, because we got 4 here, right? So this is going to be let's say 1.635 times 10 to the 4th feet, right? And then we want 3 sig figs, so we're going to round that up. Everybody okay with that? We take this 5, it's going to round this 3 up to a 4, so that's going to be 1.64 times 10 to the 4th feet. And this is, both of these are in reference to 50 trillion angstroms. So 50 trillion angstroms is equal to 5,000 meters or 16,000 feet, 16,350 feet. How can we take that cubit, those cubits, and figure out how many feet are in 1 cubit? It's going to take a proportion. Is that right?
Yes, sir.
So let's do that. Let's figure that out. So we say we put 10,900 cubits. That's an old biblical measurement, by the way. I think it's something like, I know the number because I've used that number in Bible study a bunch of times. So, but I'm not going to divulge it. We're just going to calculate. So 10,900 cubits over 5,000 meters equals no, let me see. We know we want 1 cubit. Is that right? Would that be the right proportion? And then solve for X. If we're looking for 1 cubit, how many meters are in 1 cubit? Then we could take what we know, which is that there are 5,000 meters and 10,000 cubits, and then we can solve for that bottom number. Is that right? Or we could just reduce down the proportion. All right. So that's how we would solve that section of that problem, by solving for X. So basically it would be so then we would divide both sides by 10,900. Right. And then that'll give us a number. Looks like it's going to be something like a 0.5 or something like that, close to half. All right. And that'll help us to solve for that X. So it's that many meters in a cubit. And then we could also do the same thing with the feet that we found, because we found out that it was 1.64 times 10 to the 4 feet. So we'll just replace this bottom number with that number for feet, and then we find out how many feet are in 1 cubic. All right. So let's go to the next question. We got enough room down here. All right. It says the gas tank of a luxury automobile, certain luxury automobile, holds 22.3 gallons according to the owner's manual. If the density of gasoline, so look at all the information it's given us, we always want to pay attention to that. We got the size of the gas tank, the volume of the gas tank. We got the density of gas, and it says determine the mass in kilos and pounds, right? So we know, again, we're dealing with volume and density, and we know that density is mass over volume. We know that. And if we want to find the mass, right, that's going to be D times V equals, is that right?
Yes, sir.
All right. So now here's the question. If that's the case, and density is measured in grams per milliliter, what does my volume need to be in order for milliliters to cancel and for me to get grams? So think about it like this now, G over ML times, what do I want here in the top to cancel milliliters?
Milliliters.
Need milliliters. So my volume needs to be in milliliters. So it gave us the volume in gallons. But we learned the other day that we can convert gallons into liters using a conversion factor. Anybody remember what it was? So we want to convert gallons to liters and then liters to milliliters. Anybody remember that conversion factor for gallons to liters?
0.264 gallons.
So you said 0.264 gallons in every liter. Is that right?
Yes.
All right. So now, first thing we need to do, the density is fine. We have that. We need to convert gallons into liters and then liters into milliliters. So let's do that. So we have 22.3 gallons times 1 liter over 0.264 gallons. Is that right? So we want to cancel out gallons. What do we get from that? It's about be about 4 times that number.
I got 84.47.
Okay, 84.47 liters. Is that right?
Yes, sir.
Keep in mind, we always keep track of those units. If you don't keep track of the units, your calculation is going to get lost in the sauce. So you don't want to not pay attention to the units. All right. So it's 84.47 liters, which is how many milliliters? 1,000 milliliters over 1 liter. Again, this is all development of a skill set, because what you'll find out the further we go in chemistry is all just one big conversion. Everything is a conversion. If you either going from moles to grams, or you're going from volume to molecules, or everything is a conversion. Everything is a conversion. So if you master the art of conversions, you will master many of the other parts of this this course. because everything is going to require some type of conversion. And you have to do it based on the information you have and take what you have to derive what you want, right? And that's what we're doing. We have gallons. We're using gallons to derive liters and liters to derive milliliters. So you have to also have to be some known quantities in there so you can go back and forth between different units. What do we got? What do we have? Anybody? Is it 8.447 times 10 to the 4th? Something like that. Let me get my calculator out. All right. It's 8.447 times 10 to the 4th. If we wanted to round up and get 3 sig figs, that's going to become a 5, which is going to make that 4 round up. Well, actually 3 sig figs would be 8.45 times 10 to the 4th milliliters. All right. Any questions about that? Any questions?
No, sir.
I'm hesitant to start this next part because I know we're going to get cut off. It's only got 4 minutes left. So I'm going to actually just stop here. And then on Friday, we'll start fresh with chapter 2. We're going to talk about we're going to talk about atoms and atomic theory and lead into the periodic table and formulas and naming and all this stuff. So we'll just hold tight right here. And we'll pick up on Friday. All right. Anybody got any questions? Everybody feel all right? You feel overwhelmed or underwhelmed?
Will our in-person chemistry class be next week, right? Like face to face?
No, this class is going to be fully virtual. The labs are going to be hybrid where you have some face-to-face contact.
Oh, okay.
This class is 100% virtual.
Okay. Thank you.
Yeah, no problem. Great question. I see your comment, Robbie. That would be like one of those big Ram trucks with a 6-liter engine. That's a lot of power. All right. Any questions about anything? If not, we're going to let me stop recording.